Okay, so today we are talking about the polynomial regression and machine learning. So real world business data is not perfectly linear. Okay, it may have multiple curves. Okay, for example, sales demand changes seasonally. Okay, so product wise actually. So some products have seasonal demand, correct? Customer growth accelerates and slows down. Okay, so sometimes you see there is a positive growth. Sometimes actually we see slowdown. Okay, in customer growth. Advertising spends versus sales growth. Okay, so it is not always that you if you spend on advertising more, then there will be more sales. Okay, product pricing versus customer demand. So in such cases, the linear regression concept fails, okay, to capture real world patterns accurately. Okay, so this is where, as a data analyst, okay, we use polynomial regression. In this session, we will cover the concept of what polynomial regression is, how it works, how it is different from linear regression, and other important aspects. So, polynomial regression definition in machine learning denotes a concept of a supervised machine learning algorithm, okay, used to ensure known linear relationships between input variables and output variable. The model extends linear regression by transforming certain input features into existing polynomial terms. So it allows the model to fit different curved patterns, okay, within the data. So in simple terms, polynomial regression helps in machine learning models, okay, when the relationship between variables is not linear. Okay, if there is known linear relationship, okay, then we can use polynomial regression. So let's have a look at what you would use a polynomial regression. So let's say we have this set of observations. These are the data points, right? So if you see, you can draw a line like this, okay, and all points are close to this line, right? So you can actually find a fit line, okay, regression line, okay, using this formula y equals to b0 plus b1 x1, right? And all the points we can see here, all the points are close to this line, right? So this is the case of what? Simple linear regression, right? So this line fits the data. Okay, so let's say the data looks something like this. So let's say we have this set of observations. So if you draw a straight line, okay, like this, if you see 3 points are below this line, okay, only 2 points are above this line, okay, but it means we can say that this line is not fit for these data points, right? So if we actually use linear regression, y equals to b0 plus b1 x1, okay, then the model will not be predicting accurately, right? Will not be giving output accurately. Reason, there is a curved relationship. If you see here, okay, there is no linear relationship, right? So if we try to use simple linear regression here, okay, we see that it doesn't fit quite well. So how can we correct that? We can try to correct that by using a polynomial regression. Okay, and we have covered simple linear regression, and the simple linear regression formula is y equals to b0 plus b1 x1. We have also covered multiple linear regression, and the multiple linear regression formula is y equals to b0 plus b1 x1 plus b2 x2. Okay, and pairs of what? The slope, coefficient, and the variable. The polynomial regression is y equals to b0 plus b1x, b2x square and bn xn. Okay, so we are using same variable. This here variable is x1, x2, xn. We have different variables, right? x1, x2, xn. But here we have same variable, x. Okay, but the power is changing, right? So here this is power 1, power 2 and power n. So here notice that it is very similar to the multiple linear regression. But at the same time, instead of the x, x2, x3, x4 and so on, we have the same variable x, but it is in a different power. Okay, power 1, power 2, power n. Okay, so here we have this polynomial data set, polynomial regression data set. So this is a simple data set. Let's imagine the scenario. Let's imagine that we are actually an HR department and that we want to hire someone, and we actually found someone that seems to be a great fit for the position, for the job. So we would like to offer that person a position in our company, right? And we have this data, right? We have this data, position, and this is position level, right? So business analyst level is 1, junior consultant level is 2, senior consultant level 3, CEO level 10, right? And level wise we have salaries. Okay, so this data we have in our data set. Now the candidate that we are interviewing, at the end of the interview process comes that important question. Okay, what is your salary expectation, right? So let's say that person is asking for, suppose, 1,70,000. So well, that is exactly what we are going to figure out here. Suppose that candidate is asking for 1,70,000 for a position. Okay, so using this data, if we create a model, then we can use that model, put in the person's experience, the candidate's experience, and the model will give us the salary. Okay, then we can compare. Okay, compare the salary the candidate is expecting and our model is predicting, right? So we are going to build a polynomial regression model to predict the salary of candidate. So let's build our polynomial regression model. Let's go to the Jupyter Notebook and do this. Okay, so this is the whole structure of the implementation, right? So step 1 is importing the libraries. Second step is importing, second tool is importing the data set. Next tool is, or step is training the linear regression model on the data set, and then training the polynomial regression model on the data set. Then we will visualize the linear regression results. We will visualize, and next step we will visualize the polynomial regression results, and then we will predict a new result with the linear regression, right? And last step, okay, we will predict a new result with the polynomial regression model. Okay, so this is the whole implementation structure. So step 1 is importing the libraries. Okay, so here, okay, we will be using NumPy, Pandas and matplotlib.pyplot. Okay, 3 libraries. So run the cell executed successfully. Now next step is importing the data set. Add a new cell, and you can use pd.read CSV and provide the file name. In my system, I have that file in data folder, and file name is position underscore salaries. Position underscore salaries dot CSV. Let's use data set variable. Run this cell executed successfully. Add a new cell, and to verify the data set dot head, run this cell. Okay, and in this data we have position, we have level, we have salary. Now next step should be what? Extract matrix of features and dependent variable vector, right? So if you see here, for every position we have a level. Okay, for this we have 1, for junior consultant we have 2, right? So extracting this position, okay, in matrix of features is not required, and level is already numeric. Okay, encoding these values, this data in level is not required, it is already numeric, right? Position is categorical feature, but we will not be needing this because these levels correspond to these positions, right? Add a new cell and x equals to dataset dot iloc. We want all rows, and we want this column. Okay, second column. It means 1, but we don't want the last column. Okay, so -1. Okay, so this will be excluded. This will not be actually extracted, right? This will not be taken. Dot values, and extract y equals to and y we want only the last column, all rows, but only last column, salary column, right? So here we are using -1. Run this cell, and now print x and y. Print out x, and we see this is matrix of features, and we have only one feature in this matrix. Okay, all these values 1, 2, 3, 4, 5. Okay, so these are position levels. Add one more cell and print out y. Print y. Run this cell, and these are salaries. Okay, values from this column. Okay, salary. Okay, so in x we have position levels, these levels, and in y we have salaries, right? Next step is training the linear regression model on the data set. Okay, so before actually implementing this next step, let's write code here to visualize the data, right? If you are interested in visualizing the data, whether data has that linear relationship or non-linear relationship, okay, you can print x and y. Okay, you can plot a chart using this x and this y. Okay, so to plot a chart, you can use plt dot scatter, because these are data points. Okay, use scatter and pass x as first parameter, y as second parameter, and then you can specify color, set color to a red, and optionally you can set label data points. plt dot title, set title to. So here we are showing what? We are showing position versus salary, right? X versus y. So x is position level and y is salary. So position versus salary. And next statement, plt dot x label, set x label. So this first parameter is x. We are passing x. X is what? X is position. So here we can pass position. plt dot y label. Okay, y, second parameter is y. So this y has salaries. Okay, so this is what? Dependent vector, dependent variable vector, right? And it has salaries, salary. And next statement, okay, call legend to show this legend. plt dot legend, call legend to show the legend. plt dot grid if you want to show grid, and plt dot show, okay, to show the chart, to draw the chart. Run this cell, and if you see, these are the data points, and if you see, this data doesn't have linear relationship. Okay, you can see that x and y don't have linear relationship, right? So this data is showing non-linear relationship. If you want to know the relationship, okay, between variables, if you want to find the relationship, okay, then you can draw a plot. Okay, you can draw x and y, and this will show you, okay, what kind of relationship, okay, the variables have. Okay, next step is training the linear regression model on the data set. Okay, so first we will train linear regression model. Okay, so to train linear regression model, first of all import linear regression class. So from scikit-learn dot linear model, import linear regression, and then create an instance of linear regression. Okay, let's name it regression. Regression. And then fit this model regressor dot fit, and fit this on x and y. Here, because we have only 10 rows, so we are not splitting this data, right? If you have good amount of data, okay, then you can perform data splitting also. So here we are training it on the whole data, the entire data, right? Run this cell, and we have created this linear regression model and trained on this data x and y. Now in next step, training the polynomial regression model on the data set. Okay, we will train. So here from the scikit-learn, okay, we will import polynomial features class. So from scikit-learn dot pre-processing, import polynomial features. Okay, so we will actually use this polynomial features, okay, to convert, okay, that x into some degree, right? Okay, and we will do some experiment, right? Okay, by changing the degree. Now create an object of this polynomial feature. So let's call it regressor polyreg, and create an object of poly feature. Degree is 2. So initially degree 2. Actually here we have x, right? We have this x, right? So if you want to convert it into that ax square plus bx plus c, okay, then because variable is 1, so in that case you can use polynomial features class and you can pass the degree here, okay, to convert, to create actually that polynomial equation, right? So here then use polyrec dot fit transform, call fit transform and pass x. Okay, we want polyrec to fit on x and then transform x, and then okay, we can use one more variable x poly. Okay, let's run these statements first to see actually what, okay, we will be getting in x poly. Run this and add a new cell and let's print x poly. And if you see here, okay, we have 1 1 1 1 2 4, okay, 1 3 9, right? So in degree 2 equation is like this: ax square plus bx plus c. Am I right? Ax square plus bx plus c. And if you set it to degree 3, run this cell. Let's run this cell. And if you see, now we have 4 values. Okay, 1 1 1 1 1 2 4 8, right? 1 3 9 27. Okay, now first we will use degree 2. Run this cell and now it is degree 2. Next, here after creating this x poly, use polyrec dot fit and pass. Now we will use in place of x, instead of x we will pass x poly. Let's use capital X, x poly, right? And y. Create one more regressor. Regressor 2. We already have one regressor, right? Now create one more regressor 2, linear regression. Okay, now we are going to create one more instance of linear regression and regressor 2 dot fit. Now train regressor 2 on x poly and y. We trained this regressor on x and y, right? Here we are training, we are creating one more regressor and training regressor on, okay, x poly and y, right? Run this cell and we have created one more, okay, linear regression, one more model, but this model is trained on x poly and y, right? Now we will visualize the linear regression results. Okay, now we will visualize actually both the result of this model and result of this model. Now we have two models, regressor and regressor 2. Okay, so let's copy these statements to save typing efforts. And add a new cell. Okay, here pass x, y, color red. Okay, let's set label to data points. Plt.title. Okay, title will be, okay, and do one more thing. Plt.plot. Okay, we will plot x regressor dot predict and pass x. Okay, so this regressor dot predict, okay, will predict output, okay, for x values, okay, for values for data in x, and set color to blue. So let's draw this in, show this in blue. Title, so let's results. This will be the result of linear regression. Okay, position level, x label is position level, and y label is salary. Okay, call legend, call grade, and show. And if you show, if you see here in this plot, okay, this is the line, okay, fit, but these points are not close to this line, right? Okay, so this model, okay, we trained on x and y, but this is not fit. Add a new cell here, and let's copy this. Okay, here we will plot x and y in color red and data points, and in plot we will use x and regressor. Now we will use regressor 2, right, which we trained on x poly. Okay, so regressor 2 dot product, and now here, because now this x needs to be transformed, okay, to polynomial, and we already have that polyreg. Okay, we created this polyreg, okay, we created instance of polynomial feature, this polyreg. Okay, and we actually fit, okay, trained this polyreg on x. So this x poly is, this polyreg is already trained, actually this is already fit on x. So we can use this polyreg here, polyreg. So this polyreg is that the polynomial feature instance, okay, which is already trained, okay, on x. Polyreg dot, now it is showing, and you see, if you see here, this is polynomial model. Okay, this is linear model, right? But now this regressor 2 is polynomial. Okay, currently it is actually degree 2. Okay, so we can change its degree. Actually, it is better than this linear. It is better than this linear, but still, okay, these points are not close to this fit, right? In this case, what we can do is, okay, we can try it with degree 3. So we are creating now a new polyreg, new regressor, okay, with degree 3. Run this cell. Running this cell is not required. Okay, we can run this cell again. And if you see, it is, I think, better than earlier, right? Now it is better than earlier. and we can try it with degree 4 also. Okay, to see if that gives better results. Run this cell. Run this cell again. Yes. Now if you see, all the points are very close to our model. Right? So this is our predicted points. This blue line is predicted points. Okay, predicted line. And red points are real points. Okay, and now real points, real data points are very close to our predicted line. Okay, so this model is working better. So if you want to predict, okay, we have salary of, okay, let's show 10 records. Okay, so if you see here, the salary for region manager level 6 is 1,50,000, right? And salary for partner level 7 is 2 lakh, right? Let's predict salary for a person, a candidate whose experience is 6.5 years. Okay, if you want to predict, now here we will predict salary for, predict salary for experience 6.5 years. Okay, and we will predict, okay, salary using both the linear regression and the polynomial regression. Regressor dot predict. Okay, once you have trained your model, okay, you can use predict, okay, to predict output. So if you want to predict a salary for a person whose experience is 6.5 years, what you can do is, see, if you see here, X is what? X is a matrix, right? So 1 is enclosed in square brackets and it is further enclosed in square brackets, right? So here what we can do is, we can use square brackets, and then we can pass 6.5. Okay, so we, in our data set, we know the salary of a person whose experience is 6 years, salary of a person whose experience is 7 years. Sorry, this is level. Okay, we know the salary for a person, okay, in this position, partner. Okay, position level is 7. So we know the salary of a person in this position, region manager. Okay, level, position level is 6. That is 1,50,000. So here we want to predict salary if there is a candidate whose experience is 6.5 years. Run this cell and it is predicting 3,30,000. This is wrong actually. Okay, because for 7 years, not 7 years, for level number 7. Okay, for level number 7, for position level 7, it is 2 lakh. And for position level 6.5, it is predicting 3 lakh. It is wrong. And if you see, it is wrong. It is wrong. Because data points are far from this line. Right. But if we use regressor 2, which is based on polynomial regression, regressor 2 dot predict, okay, pass same experience 6.5 years, but here we cannot pass actually 6.5 years directly, because now we need to convert it to a polynomial, right? This is linear, but for polynomial it needs to be what? Ax square plus bx plus c, right? That kind of equation. So for converting that 6.5 to polynomial, what we can use? We can use polyreg. okay, we can use this polyrec fit transform. Okay, we can use this. And in place of this x, now we can pass and double square brackets that value 6.5. So this polyrec, okay, will convert it into polynomial. Okay, and that will be passed to predict. Okay, and then it will give the result. Run the cell, and now it is saying 1,58,862. And I think it is better. See, for position level 6 it is 1,50,000. For position level 7 it is 2 lakhs. So for it is saying for position level 6.5 it should be 1,58,862. So if the person is asking for suppose 1,70,000 or 1,65,000 or 1,75,000, okay, we can use our model to check, okay, how much should be the salary of that person, right? So that's all for what is polynomial regression and how to implement it. Thank you for joining. See you in the next session.